Hello students, let's see what is homologous series. Actually, homologous series is a series of organic compounds. They are having similar structures and same chemical properties. Actually, these 2 points, these are the two important characteristic features of homologous series. That is, they are having similar structures and same chemical properties. Let's see one example of homologous series, that is homologous series of alkanes. Homologous series of alkanes. We know that alkanes are saturated hydrocarbons. They are saturated hydrocarbons and there is single bond between carbon atoms. So there is single bond between carbon atoms in the case of alkanes. They are saturated hydrocarbons. And the general formula of alkane is CnH2n plus 2, where N equals 1, 2, 3, etc. So using the general formula CnH2n plus 2, we can write all the members of alkane family. And we know that the first member is methane and the molecular formula will be CH4 and the structure is like this. The second member is ethane. The molecular formula is C2H6 and the structure is like this. So this is the structural formula of ethane. Then the third member is propane and the molecular formula is C3H8 and the structure is, or the structural formula is like this. And the fourth member is butane and the molecular formula is C4H10 and the structure is like this. So these are the 4 members of alkane family. We can write all the members of alkane family using the same general formula CnH2n plus 2. So we can see this is the homologous series of alkane. Here there is a similarity in their structure. We know that there is single bond between carbon atoms. We can see there is single bond between carbon atoms while seeing the structures. So we can say they are having similar structures. So alkane family or the homologous series of alkanes, they are having similar structures. So this is one characteristic feature. Let's see another characteristic feature, that is the molecular formula difference. So let's see the molecular formula of the first compound, that is CH4, and the second compound is C2H6 and the third compound is C3H8. So let's see 3 compounds. So what is the difference between, that means the molecular formula difference between these two, that is the molecular formula difference between successive members, that is between 1 and 2 or 2 and 3 or 3 and 4, or the successive members. What is the difference in molecular formula between the successive members? So in the case of methane and ethane, what is the difference? So we can see there is a CH2 difference. If you are adding CH2, we will get the second compound. So if you are adding CH2 with the first compound, we will get C2H6. So that is the second compound. If you are adding CH2 to the second compound, we will get the third compound. So likewise, we will get all the compounds. That is the molecular formula difference. The molecular formula difference between the successive members. So that is a CH2 group difference. CH2 group difference between successive members, or the molecular formula difference between successive members, that is by a CH2 group. So that is another characteristic feature of a homologous series. So CH2 difference. So before that we can write one more point, that is they are having same general formula. They are having same general formula. Then molecular formula difference. Molecular formula difference is CH2. So there is a molecular formula difference between successive members, that is by CH2. Now let's see what is the molecular mass difference. So if molecular formula difference is CH2, we can easily calculate the molecular mass difference. We know that carbon is having the atomic mass 12 and hydrogen is having the atomic mass 1. So 1 into 2, and we will get the molecular mass corresponds to CH2 is 14U. So we can easily say there is a molecular mass difference between successive members, that is by 14U. So molecular mass difference by 14U. So that is another characteristic feature of a homologous series. So there is a molecular formula difference by CH2 group or between successive members. There is a molecular mass difference between successive members is 14U. And we have seen the second point as same chemical properties. So in the case of alkanes, we can expect same chemical reactions. So same chemical reactions can be expected from alkane family. So all the members of alkane family or all the members of alkane give the same chemical properties. So same chemical properties we can see, but there is no or physical properties will not be the same. So physical properties of a homologous series will not be the same, but the chemical properties are the same. So physical properties will not be the same for all the members of a homologous series, but the chemical properties of a homologous series or the members of a homologous series will be the same. So these are the main characteristic features of a homologous series. So this is the case with alkanes. So the characteristic features of all homologous series will be the same. So we have proved all the characteristic features with alkane family. We can write homologous series of alkenes, or we will get homologous series of alkenes, alkynes, maybe with alcohols, aldehydes, etc. So different family of organic compounds make homologous series. So in all the cases, we can see all these characteristic features. So by knowing the characteristic features, we can easily identify the homologous series of a particular organic compound. So this is about homologous series.